Hello everyone, KP the Math G is up and ready to go again. Well, today we are going to look at some techniques of differentiation. I usually have this written up there, so forgive me for not having that. I believe I spelled differentiation correctly. Yeah, alright. I have to check because, when you're 63 like me, well, you got to check everything. And you have to check everything no matter what your age is, especially when you're doing calculus or any math related subject, right? Alright, we're going to look at this. Remember that last time we said that we can find the derivative of anything through a limit if the limit exists. Alright, so we would have something like f at x plus h plus minus rather, alright, all over h. That's the long way around, is what I said in my last video. But this is actually the definition, and you want to find, if you want to find, for example, instantaneous velocity, you use this right here. If you want to find the slope of the tangent line, use this right here. We're going to find a shortcut, and we're not going to go all the way over the river and through the woods to grandmother's house. We're going to take a shortcut and get there a little sooner. Okay, so let's look at this. We're going to apply this to a problem here. Let's see. Well, I'll tell you what. Let's pick a small problem. I have a longer problem, but let's pick something kind of relatively small right now. And so let's do this. Let's say that since we're dealing with f, let's make our function f. So f at x is equal to something fairly simple, 2x squared, let's say plus x. How about that? Okay. And we're going to find the derivative. What we want to do is find f prime at x. That means derivative right there. What's the derivative? Well, we're going to use this to find it first, and then we're going to find it the short way. So let's go ahead and get started. So let's see, 2. Remember, every time x plus h right now is going right here and right here. So 2, so the limit as h approaches 0, let's see, 2 times x plus h squared plus x plus h. There it is again, because see, there's your x and then x squared and then plus x. There's the same thing. Alright, so we've got x plus h. Now minus f at x. I like to do this, especially if I have more than one term. If I only have one term, you don't need this. But if I have more than one term, I'm going to do this right here. Alright, now all over h. Really and truly, can you tell this is not really that difficult? It's just, just work. Okay. Alright, so now we have the limit as h approaches 0 to, now let's expand this. Now remember, this is just simply x squared. Remember, this is always a 2 times the product of these two, x times h. Alright, and then finally the last term is squared. A lot of students want to just go to x squared plus h squared even at the AP level. Yikes. Don't do that anymore. Okay? Give yourself 3 terms here. Okay? 3 terms. Actually it's 4, but 2 of these go together. Okay? Alright, well, let's keep going now. Plus x plus h. Now I distribute the minus sign. Minus 2x squared minus x all over h. Let's do this again. The limit as h approaches 0. Well, let's distribute this 2 now. Alright, so we've got 2x squared plus 4xh plus 2h squared. Alright, now we've got plus x plus h minus 2x squared minus x all over h. And at this point I'm going to start looking, and now that I've distributed and gotten everything together, I can put some terms together. You notice every time these last terms, this alpha x will be 0. There will be an opposite for each one of these. So opposite of negative x squared is negative 2x squared is positive 2x squared, and negative x should be a positive x right here. So now, that brings it down a little bit. Let's see if we can, where are we going to put it? I think we got enough room. We're going to squeeze it in down here, guys. Let's see, limit as h approaches 0. Alright, so you have to understand it's early in the morning for us here, and I sometimes don't operate well early in the morning. Alright, so plus 2h squared. What else do we have? Plus h. Alright, over h. Okay, that's this right here. That's what we have so far. Lucky for me, my board flips over, so that's what I'm going to do. I'm going to flip this board over, but before I do, I'm going to write down what I've got here, and then I'm going to flip my board over. Alright, so what we're left with right here is the limit as h approaches 0, 4xh plus 2h squared plus h all over h. That's looking really nice, and there's a reason why I say that. Alright, here we go. Let's flip the board over. Okay, here we go. Okay. That was a picture of my grandson and myself. We just got flipped upside down. Well, the picture did anyway. Raw humor early in the morning, guys. Okay. I don't know how my wife puts up with that sometimes, but she does. And look here, I'm not going to write with the pencil or pen. I'm going to write with this. Okay, here we go. Limit as h approaches 0, 4xh plus 2h squared plus h all over h. Now, I want to ask you, do you see anything in common that we can factor out? And that's at this point. Every time you get down and you've already eliminated that alpha x over here, what's left? There's something that you can factor out. Seems like every time you can factor something out. Look at there. There's an h in every term, isn't it? So let's see. There's the limit as h approaches 0. Okay. Let's take out the h, and we're left with 4x plus 2h plus, 1, right? Well, some students now, they leave that one out. You have three terms and somehow end up with two. And so you don't have anything over here. Well, yes, you do. You have a 1. A lot of times I'll just say divide out by that h here, and that's h over h is 1. You have another term. If you have 3 terms here, you better have 3 terms here. And that maybe I'm just talking to my underclassmen now, not calculus students, not pre-cal students, hopefully not, but students who need to know that you have 3 terms here, you're going to have 3 terms here. Sounds like I talked before. Yeah, I did. I have talked before. Okay. Limit. As h approaches 0, well, what are we left with? Well, we just have 4x plus 2h plus 1. If we let h be 0 now, right, so we have the limit as h approaches 0, 4x plus 2 times 0 plus 1. And now we see now that we have the limit as h approaches 0, 4x plus 1. So, I don't know, let's put something up here. So what? So, well, f prime at x is equal to 4x plus 1. So if we wanted to make some application of this, we could make this t, f prime at t. Alright, so, or we can leave it at x, and we can say, well, alright, at x equals 3 seconds, we're going to have, this is going to be in, and I will say that what we just did the derivative of in terms of limit, using limit to find that derivative of the original problem that we just put up there, we found that that would be like saying that is in feet, distance. This now is feet per second. So at 3 seconds we have f prime at 3 seconds is equal to 4 times 3 plus 1. That's 12 plus 1 is 13. So that f prime at 3, after 3 seconds, we've gone 13 feet. So in this case, 13, if we have this in feet per second, then it would be feet per second. 13 feet per second, miles per hour, and so on if you wanted to do something like that. Okay, dollars per hour. Ooh, that wouldn't be a lot of money nowadays. $13 an hour. I've seen the day when that would be. Whew, oh yeah, I want that. Not anymore. Alright, so that is the long of it. Basically that's it, but I just wanted to show you some little application that you can remember, okay, along the way, that you can use this. Now, okay, let's leave our derivative up there. Let's leave that, and let's erase all this other work. Tonight we erased all that good work. Yeah, we're going to erase all that good work, and I'm going to show you, put the original problem back up there, and I'm going to show you that we get this doing another way. As a matter of fact, this technique, we're dealing with technique, remember. So the first technique is called the power rule. The power rule, or the power technique. Power meaning exponent. Power rule. Well, it doesn't mean you have to have muscles to do it. Muscles are coming out a little bit. I work out in the gym, but doesn't show a whole lot, but hey, I feel pretty good at the end of a workout. Pretty good. That's all that matters to me. I feel good. At my age, that's good. Well, let's do the power rule. Let's go back to F, what we originally had. I'm going to have to look on the other side of this board to see what we had. Well, let's see. It was, what was it? 2x squared plus x. Okay, 2x squared. 2x squared plus x. Okay, that's what we originally have. Now f prime at x. Now you're going to be saying, KP, the math G, why couldn't we do this from the first? You want to learn how things are done from an original, you know. If we started with limit and the limit leads to a derivative, then let's use the limit to find the derivative. Okay? That's what you do that for, so you can see the origin of things. That's what you want to do in mathematics as a mathematician. You want to see the origin of things. Okay? Where did it come from? You can't just go from here and say, oh, this is this. Well, we know we found it by using the limit. Let's see how we find it doing something like this. Now, let's put down a rule. A to the n, ax to the nth power. If we take the derivative of that, if we say that f, then f prime is going to be this, a times n. A times the exponent, the power, a times the power, we're still going to keep x, and we reduce the power by 1. Okay, n minus 1. Okay, so that's what we're doing. We're going to take the exponent and multiply it by the coefficient, and then we're going to reduce the exponent by 1. Well, let's see what that looks like over here. I'm going to erase this. This is a nice little rule. And this is really what you look for the first thing. In case you can't do that, there's other things we got to do. But this is the fundamental thing that we do first. Okay, so let's take this. Let's take the 2 times that 2 up here. We're going to reduce the exponent by 1, so 2 minus 1 is 1. Now remember, this has an exponent too. It's 1. Keep that in mind. Okay. So what we have here is, I know we're going to put there's an understood 1 right here, isn't it? So 1 times 1 times x. Uh-oh, if we reduce this by 1, what's the exponent going to be? Well, it's going to be 0, isn't it? Okay, well, let's see what we get here. F prime at x then is equal to 2 times 2, which is 4. X to the first power, I'm not going to put that first power there. 1 times 1 is 1, and actually x to the 0 power, remember that rule, is 1. So this is going to be 1 also. 4x plus 1, look at that. You know, in the story of Little Red Riding Hood, remember that the big bad wolf found a shortcut to grandmother's house. Well, I'm not the big bad wolf. I'm KP the map G here. So just a short way. Okay. Good news is nobody has to throw anything at me to say, hey, why didn't we do this the first time? Okay. All right. Enough of the bad jokes. Okay, but there you go. You see that, don't you? Let's do a little bit. Let's do another polynomial that has a little more to it. All right, let's do that. Let's keep that power rule going, guys. All right, power rule. How about that? That's nice. Power rule. All right. Well, let's see here. I think we need to do something like this. Hey, I tell you what, let's do G. I'm so CF all the time. I want to do G this time. G at X. Let's try this one. It's going to be 2x to the fourth minus 4x to the third plus 2x squared. Let's see, plus 5x minus 4. Oh, water's running in the bathroom. Evidently my wife is awake now. So if she hollers for me, I'll stop this video pretty quickly. Or say, give me just about 5 more minutes. Okay. Alright. Let's find G prime at X. Alright, again, the power rule means we multiply 4 times 2. Let's just go ahead and multiply that. 4 times 2 is 8. Remember, we're going to reduce the exponent by 1. So 3. Alright. Alright, there we go. There's the first one. 4 times 3. 4 times 3 is 12. We'll reduce the exponent by 1. 3 minus 1 is 2. Plus 2. 2 times 2 is 4. So 4x. Reduce that by 1. We got 1. And I hope you get where you see this, that when you reduce an exponent, when you just have an exponent of 1, it's just that constant. We can just say 1 times 5 is 5. I want you to get where you do that. Remember, if you reduce that exponent by 1, that is 5x to the 0 power, which is just 5 times 1, which is just 5. So just get where when you see that exponent of 1, you just say, 5. Okay, then minus, whoa, now don't make a mistake and put 4 here. That is not so. That is certainly not so. Derivative, this is a constant. The derivative of a constant is 0. Okay. Well, it's just 0. And so we don't need the 0 at the end, so we can just say then G prime at X is equal to 8x to the third minus 12x squared plus 4x plus 5. Okay. Right, and then again, if you want to find the instantaneous velocity at t equals 1, you can just plug 1 in, can't you? Okay, this could represent the slope of the tangent line. So, okay, so what is the slope when x is equal to 2? I tell you what, I'd hate to put this one into this original problem and erase all these minuses and times and all that. Okay, I'd hate to put this one into the limit, don't you? I mean, we'd have to put x plus h here, x plus h here, x plus h here, and x plus h here. And the problem with x plus h here, you're multiplying x plus h 4 times, you're multiplying x plus h 3 times, you're multiplying x plus h 2 times, and then this is just 1 time. And then you still got to do minus g at x. So minus all of this. Wow, that would take a long time, and we don't have enough video time for that. This is the power rule. Okay. So that's kind of where we are with this. I was wanting to kind of get you familiar with the power rule. There are occasions where we might have something like this, okay? Keep in mind that on each of the exponents, you reduce the exponent by 1. Well, what if we had something like this? I'm going to try to make g at x a little simple here. 6x to the 4th. And then let's do a couple more terms here. So let's make this minus 5x, and let's put a negative exponent up here to say the negative 2. All right, and then let's do another one. Let's do plus right here, and let's make this 3x. Let's make this to the negative 3. Okay. So the power rule applies the same whether you have a negative exponent or a positive exponent. And say, well, KP, can we just rewrite this? And you know, if you have a negative exponent, you can rewrite this and have a positive exponent in the denominator. You certainly can. You can rewrite. I'm just going to put it up here. You can rewrite this, but I don't want to tell you the truth. I'm just going to show you this in just a moment here. If we have g at x, I can rewrite this so that the negative exponents are positive. 6x to the 4th power minus 5 over x to the positive 2 plus 3 over x to the positive 3. And that's, yeah, of course you could do that, but I like doing it. This is okay. And if you start off with this right here, you can rewrite it. I would recommend, a lot of times they say, get this derivative here. What is g prime at x? And they have this, what I'm saying is they have this as the original problem. We'll rewrite it so that you will have it as looking like a polynomial like this, okay, where you have everything in the numerator. Remember, if you have this in the denominator, this will be negative in the numerator, and then of course same thing here. And you already have a positive here, so you don't want to bring that down. It's already positive. So this is positive. I can make it negative and look like this here. Okay, now g prime at x. Let's do this. 6 times 4 is 24. All right, now remember, you're reducing this by 1. This is going to be x to the 3rd power, isn't it? Okay. And then again, look at this now. A negative times a negative, negative 2 times negative 5 is positive 10. Be very, very careful with that. Positive 10. Now remember, if you reduce this by 1, that's really going to be negative 2 minus 1, which is negative 3. You still are reducing that by 1, so that's what you can do here. Alright, then again, the same thing. Negative 3 times 3, instead of this being positive, this is going to be a minus sign here. So negative 9x, and then if we reduce that by 1, you'll get negative 4. There you go. Now if you want to write this where you have positive exponents, now you can say g prime at x is equal to 24x cubed. Now plus